Greeting friends of chemistry. Martin and I are working on Module 7 practice problem number 2. Will you read it to me, please?
Which of the following atoms are isotopes? 22 Na, 22 Ne, 23 Na, 22 Mg, 24 Na.
Did you say Ng? I didn't think there was
Mg. I think that's magnesium.
It is. Sodium is Na.
Okay,
which of these are isotopes?
It's all the NAs. Nada. Natalie's it.
Are you sure?
Yeah.
It's not a trick question?
I thought it is a trick question.
Okay.
You trick me?
So isotope is a relational term, right? It tells you how the atoms relate to one another.
Yeah.
Right? So these relate to each other because they're isotopes of sodium.
Yeah.
Okay. Number 3. What is the symbol of the atom? Made up of 39 protons, 45 neutrons, and 39 electrons.
39. It's Y. 88 Y. Wait, no, not 88.
So it's yttrium.
Yeah, yttrium.
Okay, capital Y.
I found it on the chart because it's easier to search atomic numbers that way.
That's fine.
Okay,
yeah, and you can tell the atomic number because of this, right? 39 tells us the atomic number. So 39 is yttrium. And what is the other part of the question? Sorry. What is the symbol of this atom?
It's Y.
But that's not it.
88 Y.
Okay. So we're going to come up with this number here.
Oh,
and what is it going to be?
84 Y.
We have to add these two numbers. We
That's
never add the
84
electrons, right? We're never going to add that up.
Okay.
So we have 84Y. The correct answer for number 3. Okay. Now we're looking at number 4.
If light has a frequency of 1.2 times 10 to the 14 hertz, what is its wavelength?
Okay, so here we need to know the equation. What is the equation?
I'm looking.
Now, you're supposed to have it memorized at this point.
The equation is, we're trying to find the wavelength, right?
Frequency is, so F equals C over lambda.
Wavelength. Okay. Okay, so that's, yeah, lambda, did you say? That's how it's pronounced?
Okay, so?
So, F is,
what is hertz? Okay, so we're given the answer. Frequency equals 1.2. Can you look at the question?
Hertz is a unit of measurement. You asked what hertz is.
Yeah, 1.2 times 10 to the 14th.
Yeah, hertz.
Okay, HC. What's a hertz?
A hertz is
a unit meaning.
It's a unit meaning 2 wave crests per second.
No, it means
2.
1
2.
No, you're reading this.
1 per second.
You're reading something else. Look, 1 per second.
So I see.
Look, 1 per second. Okay. So this is.
Wow, that's a lot.
1.2 times 10.
It's like a quadrillion.
Can you let me talk and not you at the same time? 1.2 times 10 to the 14th, 1 per second. Okay. Now, we also have to know what is the speed of light.
It's 3.0 times 10 to the 8 ms.
Okay.
Meters per second.
We have then here 1.2 times 10 to the 14th, 1 per second equals, what is it again? 3 point 0 times 10 to the 8th. And what is our units, please?
Hertz.
No.
Meters
For the
per
speed
second.
of light. Thank you. Meters per second.
Yeah.
Divided by some wavelength that we don't know yet. So how do we solve for the wavelength?
First we can cancel out some of them tens.
Stop. Look, let's just reset our problem here. F equals C over wavelength. Therefore, F wavelength equals C. Therefore, wavelength equals C over F. Okay? So we want to just rearrange this. So we have 3.0 times 10 to the 8th meters per second divided by 1.2 times 10 to the 14th one per second. What's going to happen with our seconds? They're happy. They're going to get rid of each other.
Yes.
And the 1 per meter is, or the meter per 1 is just the same as meter. So we're going to end up with units of meters, which is great because that's what we want with wavelength. All right. So we have 3.0 divided by 1.2 times 10 to the 8 minus 14 meters. Okay?
Yeah.
Got my little calculator. Would you like to do it?
What?
Or do you want me to do the division?
I think I already figured it out.
Really?
Oh, I put them in upside down? Oh.
Over here. So we have
How did I do that?
2.5 times 10 to the negative 6 meters as our wavelength. That make sense?
Yeah.
Okay. We're going to pause here and come back with another video.